I've knocked the flash off it, had a bit de-ragged it, a bit clean up on the wire wheel. The textures look quite nice, very happy with the casting. We'll machine these top faces, these ribs first, and everything else will be machined off them. Face is flat, it's as flat as a casting, flat as a pattern, and I rubbed it up on me big sander. Clamp it there and there, and face the tops of those ribs. It's just a nip, you don't want to put any stress into it, just enough to hold it down. So all I want to do is machine those ribs. So what I'll do, I've got a nice carbide end mill, I'll run it really fast and get a good finish on them. Don't be tempted to put a milling cutter on there, that's for drills. All I'm going to do is machine the top of those flat. I'll not be taking very much off them. Take a 15 cup, axis is locked off. Made a nice job of them. A couple of parallels underneath it. Make sure it's seated down properly. It's gripping the parallels, the vise is nice and tight. The fly cut on the centre of the job. Got that flat, all I want now is a reasonable finish on it. That's nice, put a nice finish on. Whisper in there, taking about a 3 or 4 pound cut. This will be its final cut. once you get the two slots in, what happened was I think I was on this one here, I turned the wrong handles, I turned the Y axis into the Z axis, and I put that cutter into there. So what I've done, I've made all four the same, so at least it looks symmetrical. I'm going to do remake the part, I'll cast another one and do it again, but I'll just carry on machining with what I've got. The next thing is now I want a hole, there's a hole to go in there, it fits over there, bollocks. I want to bore the hole in the middle. I've marked it out, I've marked my centre out, it's just the centre there and the centre there. I'm going to centre pop mark. I'm pleased with the finish I've managed to get on it. The aluminium's excellent, there's no blowholes in it at all. I think I've just mounted in the base again on the milling machine. Bore that hole in there. One thing, this vase, the vase came with a milling machine, it was already done. It's got a couple of dowels in there that are a good fit in the T-slots. It lines the vase up. You go on there, it lines the vase up nice and accurately. They fit into the T-slot. I think I've just simply mounted it like that, bore the hole in. What you must do is make sure your part's nicely bedded down. Which it appears to be. What I made do was drill the hole in there and then turn it over. Mount it on that face, because that's the face there that has to be parallel with that face. And what I'll do, I'll drill the hole and I'll turn it over. Line the point up, touch it and stop it moving. If you line one axis up at a time on the cross, you can get within a couple of thou, which is all I need. Spot on. The sheet is nice, this aluminium. Right. Turn it over. bed it down so it's excellent. Pick my centre up again. Which is there. Put the DRO on, 0 it all. Lock the table off in both directions so it can't move. Excellent. Right, want some holes putting in there. It's a big machine drill. This one's 1:30 in 30 seconds, 1.5 inches, just another 1.5 inches. I've machined the ends down to 15mm so they fit in the collet. Ideally if I can get a big hole through, getting shot of material in a hurry. Bastard. Get the drop with the collets in. The old machine down to 15mm, so they will fit in the collet. Just see how straight they run. Pretty good. Right, we'll slow this down dramatically. Do it. We'll put a little jack under the end of it just to stabilise it, stop it from tipping down. I got 4 of these. I got given to us by an old guy, old machinist who retired. He made them himself. Yeah, we'll give that a try. But still running about on the fast side. That looks better. See, all I want to do is get a hole in quickly with a minimum amount of swarf. I'll certainly put a hole in quickly. Messy bastard stuff it is, aluminium. That's the tool I'm going to use. It's a boring head. Cut it adjustable. It's on a slide, on a T, on a slide through there, so you can move the cutter in and out. It's graduated. This one's actually imperial. Just touching there, so I put a 10, 20 thou cut, 20 thou side. There's a fine feed on the quill. Here it engage. Fine down feed, we'll just use that. There's no power feed on it. Insert it away. quite nicely. We'll do one pass and we'll do a measure of it. Oh, that looks reasonable. That's nice. It's similar to boring a hole in the lathe, except you're spinning the tool, not the part. What will happen is there'll be a fair bit of spring in the tool, so it will take another. That would take some water out or put it through again on the spring. The spring cut. I thought going to that. I'll put in that cut through on the same setting, spring cut. Taking nothing. Taking nothing. A couple of thou. Hopefully I can get enough. Yeah, should be low. That's probably, that will actually go in there. What I'll do, I'll take one more cut without touching anything. It's actually going to get a split in there. But I'll take one more cut, like a spring cut. Taking nothing. We'll dial a Nadji's whisker in. The Nadji's whisker's not very much. The same as a hair and that's bollock, not that much. Nice. Time it gets a split in there and it's clamping bolt, it should be just a job. Two of the thickest up. You can actually see what you're doing. Pleased with that, to put a nice finish on. So now that bore is parallel with those faces there, which is the important thing. What we need now, we need to put a slot in it, slit and saw. So I'll have to do have to mount it that way somehow. I'll bolt it to a faceplate or something like that and put a slot in through there. We've got to stick it up in the vise like that. Probably spring around a lot. We'll bolt it to a faceplate, slot in there. You see, I got this boring head given. It actually had a tool. The tool had been welded into there. It was cracked across there, and the tool was welded in. I managed to salvage it. It's quite a reasonable one, but you can buy them cheap. Very handy bit of gear for the mill machine. It's an angle plate. First thing I'm going to do is mount it square to the bed of machine. And just check it with a square. Excellent, that's dead square, and it's obviously dead square that way. That's the idea of it. It's used to something flat, held across the back of the table there, pushed it up against it and tightened it up. Try and make things easy for yourself, as no need to reinvent the wheel. Right, so I've got that tightened down. You can mount our job on there and then put a slot through there with a slit and saw. I'm going to make sure I do it that way. Make sure I've got enough travel on the machine to get the saw in. That's the saw I'm going to be using. Right, that goes under there, something like that, and that goes into there. And then we'll mince that across the little cut our slot for. So that one's bolting onto there like that. It's important that this is square up and down. I'm sure we'll find some way laying that up, because at the minute we've got nothing sort of flat. But I'm sure we'll think of something. Like a rough cast edge. It's reasonable, but it's not flat. What we can do, that lines up. That slot there lines up. We can line that face up there with the edge of that, and that'll get one in the ballpark. And we've got enough. Yep, perfect. We'll put a couple of bolts through there. A couple of 10mm bolts and washers. There's enough, it's going to work out nice. Try that way around it. Slack on that. On there, we're going to line this edge up. Put a nip on them. See down that edge there, we can take it that way. We can use what precision optical alignment or eyes, and I can get that within. I can get the light of it. I can put a clock on there and run a clock up and down that slot, but for what it's got to do, that's be perfectly acceptable. A shortage of 17mm spanners by the look of it. Spot on. Right. We've got what? We're slipping saw, my blow me a hole that. Quite a fearsome device. You've got to run these slow, really slow. We're going to make sure it's on the right way up. It goes that way, it's on the wrong way up, so we'll turn it over. Right, we'll get that mounted into a collet and get it lined up for a cut. Right, we've got our tool mounted. Let's lock our blade up. It's not the sharpest thing in the world, this, but I think it'll probably do the job for us. We've got a scribe line through the centre. Squeeze the back of my twat head. Right, we've got a scribe line through the centre, and you can see it there, not line we used to mark it out with. Line there, that's the line we're going to be cutting along. I'm going to put the cut on. I think we'll do it in stages like that, we'll just do it by hand. I want this running slow, really slow. It's as slow as it'll go. It's actually doing 200 RPM. Could do it slower, but the machine won't go any slower. Running reasonably true. Okay, so I locked off that way. I'm not in a hurry to cut this. Right to the centre of the line anyway. Slight kick in the blade. The blade was second now when I got it. It does what I want it to do. Oh, you bastard. Yeah, what it's doing is picking aluminium up and blocking the teeth up. I'll put some lube on this. There's a fighting chance. I normally use WD-40 on aluminium. I haven't got any at the minute, so we'll just try a bit of this. That's making a massive difference, just that oil's making a big difference. Massive difference. I think that's it through. First thing you're going to do is take that out of there. You didn't want to get your hand cut on there. It's not that sharp, but I can assure you if you get your hand stuck in, it's not going to do you any good at all. It's possible the teeth are a bit fine on this for cutting aluminium. I know it is blunt, but it's done the job. When you get things for nothing, you just accept them and use them, say thank you. Right, so we've got a nice slot in there. So now that'll go through there. That'll be clamped on there, and that's what stops it from turning. So you want to add drilling and tapping for a Allen bolt. Put a bit of scrap aluminium in the split, just to stop it flexing, so I can machine the top of that flat. enough to make it flat, and I can drill and tap a hole in there, 6mm hole for it. I was going to put a pinch bolt in, but I think I'll put a stud and a nut in. Trouble with the pinch bolt, it's aluminium and the threads will wear. I will find the centre of it and then put a hole in. Here we've got our wiggler mounted, my chuck. Gently move along till it stops moving. Freezes there. Put it off line. Zero our counter. Other side. Stops moving, moves off there. .8412 inches, which is 0.42. It'll be near enough. .42 metre, .421. That should be our centre. What's happened here? And 5mm drills, we're tapping drill for 6. Measure how much we've got. 1.3. So I would go down 1.2. I don't really want. I don't want to break through there, so I'll go down 1.2. Nice there. Right, we'll zero our z-axis. It's on inches. 1.1. And now I want a clearance drill. This is about, I normally use a quarter, which is 6.2. Bring on again. A bit of plate so it's too far enough. .6mm top. Okay, so that's the bottom of the hole. So we're on the top again. It's all the shapes with the hole. Right down the bottom. Excellent. A bit of brake cleaner. Clean the cutting oil out. I've got a stainless steel stud here, which will probably be long enough. It is. We got a couple of nuts, and we'll put that in. Little drop of Loctite. Not too much. So I was gonna counterboard it and put a cap head in, but the trouble is that the threads in the aluminium get worn and they end up stripping. Yeah, that won't. That goes in there, with the shoulder. And that locks it up quite nicely. There's still a gap, it's not fully closed, so that's got a good hold of it. Very nice. A few rags to knock off it, but basically it's looking something quite good. So how it mounts on, so you can have it, you can put it anywhere you want really, it's whatever's convenient for what you're working on. Be the milling machine or the lathe. The chuck goes on this end, there's a change wheel that goes on there with a locking device, and you have a compound of gears on here. It's the same as a banjo on the back of a lathe for screw cutting. The compound of gears on there, so you can basically divide anything you want. You can next job with the machine have this shaft down to size. You take the box for a change wheel. There's some threads on the end for a lock nut to make for it, and there's a key with the machine in there.